Hey, welcome back to another training video. My name is Chris, and today we're in CCAM Pro focusing on a very specific toolpath known as indexing flutes. We're going to answer two specific questions, just like all the other basic toolpath videos, and that is, what does this toolpath do? And what does the cutter actually do to the part? And how does it travel through the part? What's the actual path of the cutter through the material? And then two, how do we program it? How do we control it? And we're going to answer both of those questions in this video. We're going to help visualize that using 2D drawings in our Aspire software, as well as going to the machine and actually watching the cut take place on the spindle. So let's get started by first jumping over to our Aspire software. Okay. Now this indexing flutes is actually the first type of process that is not a turning process. And what I mean by that is, so far, as an example, if we have this blank here, we have a square section, and a round section here in the center, right? And in all the other videos that we've been talking about so far, they've all been for turning procedures, like the surfacing cutter to turn the stock round starts here and then travels down the stock till it gets to this point and then lifts up out of the material. And that is a turning procedure. Same with this, like this is a tool profile that is cutting at this position here and cutting at this position here around the circumference of the part. So the cutter and the material are moving simultaneously to give us a turned detail of some kind, and that's what we've been doing. This toolpath specifically is called indexing because what that means is that the part is not rotating as the cutter is going through the material. It's going to be held stationary in place while a cutter does a detail to a single surface. It will then reposition, if necessary, to a new face, index the part, and then either repeat or do another process on that new face. So this is indexing flutes. And so what this is going to do is we're going to be using usually a ball cutter for a majority of this process. And as the blank is stationary, not rotating, the cutter is going to plunge down into our material, and then it's going to cut straight across at and come to an ending position, and then lift up out of the material, and it's going to leave this groove. Okay, this profile cut down the length of the part in a straight line. Again, the part isn't rotating during that cutting procedure. And then the entire part is going to rotate a certain number of degrees to reposition to a new face. And we're going to repeat that fluting process again and again and again. It's going to break up as many flutes as we wish around the circumference of this part so that everything is evenly spaced. But again, the cutting result makes it so that the cutter, when entering and cutting the material, the stock is not moving whatsoever. Okay. To help visualize this even further, let's bring out some drawing here so you can kind of see what's taking place. I'll just center that. Okay. So this is an example of some fluting that would happen. And so again, the cutter just plunges at a single point, travels down the stock, lifts up out of the material, repositions to a new location, and repeats the process. Okay, and you can see how it would evenly space this around the circumference of this is a cross-section view around the circumference of this diameter section for these number of flutes with the shape of cutter, right? So we can now go to CCAM and program this relative to this information. Now, you don't have to draw as much detail as what I did here in order to program the flutes, but you do need to have something that represents a starting position and ending position for the flute itself, and we'll get into that in just a moment. So that's why I drew this out, so I knew exactly where to measure from for my start and end on this flute section. So this top one here is unnecessary, this bottom is unnecessary for programming, but it's nice to throw at least one flute in there so I know what I'm measuring. Okay, so if we go here to CCAM Pro, let's open up our project here, and under training samples, like we've been using here in the past, we're going to go to our turning center, go to our turning round sample. It is still turned round. And we have some toolpaths that have been laid out already for this part. For example, it's been turned round and the two profile cutters have already taken place. And if you don't know how to program, the turning round with the surfacing cutter or do these tool profiles on the ends, we've already done those videos. I highly recommend watching those. They are going to be some critical tool paths to learn how to master for any type of turner with a legacy CNC machine. So back to CCAM Pro here, we're going to be adding a toolpath now under the indexing process. So eventually we'll cover all of these, but the first one we're going to cover is flutes. So indexing flutes, and we're going to push add and close. So indexing flutes is specifically designed to be applied around a round circumference of a blank. So again, just like this is round. So this is round, and that's being evenly spaced around that surface. So that's how we're going to divide these flutes up. So let's go over here, and we're going to go into our flute toolpath, and we're going to fill out these parameters. So the first field is pick a cutter. And you could really use any cutter to create a flute of some shape. Traditional flutes, though, are usually made with like a ball cutter or core box cutter, something that has a radius to the tip. I'm going to use a 1/2 inch core box cutter. That's what I had in the drawing being visualized. So let's select that tool. And this will be tool number 3, since the surfacing cutter and classic spiral cutter are already being used for tools 1 and 2. Now we get to choose where the flutes start and end, just like almost like a spiral twist process, but it's not going to be spiraling while cutting these flutes. It's just going to stay stationary and then re-index between them. So the flutes themselves, and this is entirely preference, by the way. You could have the flute start right where the profile is, and it will kind of transition the flute into the edge of that profile. I call that almost bleeding out the flute, where it slowly works its way out of the material. But most flutes are typically, you have a start plunge position and a end plunge position of where it starts and ends. So a lot of the time you have these kind of above the flute sections that are just traditional round or square sections like you see here. So if we measure that from a horizontal dimension from the left edge, which represents x0, and we're going to measure to the center of our cutter. Okay? So that's the center of the cutter is going to be plunging there. And from x0 to the end of our cutter right here, or the center of the cutter at the end, that's the ending position. So there's our starting and ending position for that flute. So let's come over here and put those in, 7 and 11. 7 and 11. Okay, and we're going to keep everything default for now. That's already pre-filled in. We're just going to fill out the parameters that are empty is what we're going to focus on in this video. In other videos, we'll show how to modify this for different results. But for now, let's just get started with the basics. So we get to choose what do we want as a cut depth at the beginning of the flute. And if we wish, we can also have a different cut depth at the end of the flute. In this layout, I'm going to have the same cut depth all the way across, which is a traditional flute design through and through. So what is that cut depth? Well, over here, this is where having a cross-section view is a big advantage, because we can measure from the surface, the top of the diameter section, down to where the tip of the cutter is to get a cut depth. I'm not using the full shape of the tool. You can actually see that if I brought this over here. Okay, so that starts here and then plunges down, right? So you can see I'm not using the full shape of my cutter to give myself that flute design. And so we can measure what we want our cut depth to be based on that layout. So if we go to our dimensioning tool again, and this time a vertical dimension from the tip of the cutter to the top surface of this diameter section, and that gives us a cut depth of 0.1875, 3/16 of an inch. So let's go put that in CCAM Pro. So 3/16 is going to be our cut depth of 0.1875, and we'll match that as the cut depth at the beginning and end of the flute, right? So it's the same cut depth all the way across the length of that flute itself. Now we get to choose how many flutes we want to have evenly spaced around the circumference of this part. And you can have anything in here from 1 to, again, as many as you want. Traditionally, most flutes, okay, just traditional flutes in general, Usually have it to where the width of the flute is close to matching the gap distance between the flutes. Okay? It doesn't have to be that way. That's just traditional, right? Just like a barley twist, it has a traditional 1 start, and a rope twist has traditionally 3 starts. Doesn't mean you have to use that many starts. We can choose. This is no different, okay? We can, but I did lay it out as a traditional spacing, so if you wanted to see what that is, the spacing, or should we say the width of that flute, just so you have some numbers to work with, is 0.4712. We're not going to use that. And then the gap spacing between the flutes, that distance is 0.5049. So those numbers are really close, which is why I did this many flutes spaced around, which is 8. And so we don't need, again, any of that information. That's just there to help determine how many flutes we wanted to place around the circumference if you were just paying attention to that spacing. But here we can put in 8. So let's go here to number of flutes, 8. And then we choose what is the section diameter that this fluting process is taking place on. And that is no different than the rest of our turning processes. And we can measure that here in a vertical dimension from here to here. And that is a turned around section of 2.5 inches that these flutes are being placed onto. So our section diameter here is 2.5 inches, and we can finish and save. Now we can save our program. And again, these 2 toolpaths have already been cut on the machine. We're waiting to just perform the indexing flutes on this blank. So let's generate our G code. And now let's save out our G code. And just like the others, we'll put it under our toolpath techniques for these demonstrations. And this will be indexing flutes. And so indexing flutes, G code. Whoop, G code, and save. Now let's go to the machine and see this first indexing process take place. This 1/2-inch core box cutter will plunge into the material for its first roughing pass, traveling down the length of the stock. Between each flute, the cutter moves out of the way and the stock indexes to its next location and repeats this process for all 8 flutes. The spacing is automatically going to be divided evenly based on how many flutes were programmed within this toolpath. You should now have a basic understanding on how to program this indexing flute toolpath. Go out and give this a try yourself. All the cutting advantages shown here are automatically implemented into CCAM Pro. Now, these types of videos generate a lot of different questions. I recommend you take advantage of 2 resources to answer your questions. First is head on over to our website at legacywoodworking.com. There you'll find all the different product information, additional cutting demonstrations, and much more. The second resource I recommend doing is actually getting in contact with one of our CNC experts. You can call them at 801-491-0010. They will be happy to answer any of your questions, put on software or cutting demonstrations with the machines, and point you to additional resources, again, to fulfill your needs. Now, if you'd like to just simply watch more videos, I don't blame you. Just click right over there. I think we all know what to do. If you want to be notified of future videos, just click that button down below, and don't hesitate to give us a like if you liked what you saw. As always, thanks for watching, and remember, Legacy solves more woodworking problems and allows you to say yes to more opportunities than any other CNC manufacturer in the industry.